Hey everyone, welcome to another episode of GenAI Vlog. In this episode, we're going to be talking about a couple of interesting things. We're going to be talking about Anthropic, Chainlit, MCP, and text-to-SQL agent functionalities. We're going to combine all of these topics in one quick episode, and we're going to do this end to end. So right in front of me, I have this app build. It's deployed locally on a local host for range 8,000. Very simple app, right? You can talk to it, hi, and then it's a SQL Assistant, right? I will physically run SQL query for you against some sort of toy database. You can, for example, say how many rows are there in the table, and then it will actually be able to answer that question for you upon successful running SQL query. So it actually is attempting to run the SQL query based on this response. It actually failed the first time, but that's okay, right? It actually recognized to run for a second time, and so on and so forth until it get to the final answer. So something like that, it's interesting. Let me show you how to do it. So this is my terminal window. Let me cancel that. And then just a quick note, you can actually do this in MacBook as well as on a Windows system. If it's in a MacBook, just open your terminal. If it's in a Windows system, just open WSL. So if you don't know what that means, press star and then type in WSL. The first link pop out, this penguin icon, you can click on that. That will prompt you this workbench. So you'll be able to run this system on your Windows, just like MacBook, and the command are all the same. So let's take a look at the directory. This is the directory that we're going to do. In this video, we're going to do everything from scratch. I am going to go to a different directory. So I'm going to cd upper level, and then what I'm going to do here is I'm going to do uv init project number 2. If you do not have uv, you can do pip install uv, just like that. Since I already have it, then I'm going to do uv init project number 2. In this case, you can see that project number 2 is being created. And then what I'm going to do is cd in there, and let's list out the directory. This is a project that's ready to go. So right off the box, you can see the TOML file. There's nothing in there, no dependencies, things like that. What we're going to do is we're going to install them one by one. If I scroll up, I actually have these dependencies left over from the other folder. This is a proj folder, right? So we're going to install Anthropic, Chainlit, MCP, Pandas, .env, and SQLAlchemy, and last but not least, Tabula. So very simple. We're going to say uv add, and then we're going to type in all of these things. SQLAlchemy and Tabula. I believe that's everything I need. This will be able to get all the dependencies in there. And then to prove that out, we do a TOML file, print that out, and then this dependencies is here. So we've installed this successfully upon this Python requirement, and we are good to go. So let's clean this up, and then I need some sort of a script, right? So let me create an app.py file, and then let me paste the entire script here. Let me zoom in a little bit. So that's where we are talking about, right? We have a fake data frame table. We have system prompt. System prompt needs to know what the schema is. If you don't know what a schema is, obviously a large language model will not be able to guess what these things are, right? If you don't tell LLM that you have a column named user ID, it doesn't know that, right? So the schema, obviously, you have to physically provide that information here. After that, you have a couple of helper functions to define and add and extrapolate the SQL query from the Markdown file. And then you can then execute the SQL query. Here, this helper function allows you to run SQL query against the database. The database is set up because we have a connection here based on this engine. This engine is created using SQLite. So it's a very simple database, something like that. Just build on the spot locally, nothing fancy. And then it gets to the tool calling, right? This is native to the agentic framework. In reality, you can build this however you want. There are more than one ways to go about it. In this simple tutorial, I want to be very simple, right? No helper script, everything is in one script, right? The backend and the front end is smushed together using Chainlit. So whenever you see a Chainlit, that is telling the UI that, hey, we have something here that is called a tool. And then inside of this function, it's an async function, and then essentially runs a SQL query that is a function that we just defined. And then the Claude, which acts as a foundational model, now has these tools collected inside of this foundational model. So in other words, the Claude API, right, this Claude client knows what these tools are. And these tools, obviously, the MCP tools is part of it, right? So if you have a query SQLite tool, this large language model knows about it. Okay, so if users talking about something that requires a tool calling, then it can actually look into these tools to understand that, okay, this function is required to be called, but let's try to call it. So that's what the logic is going on here. Everything else is straightforward. Message, get that in there. System prompt, get that in there. You have your model ID, max token, things like that. Chat messages is a stream of historical conversation, and then you stream it. Streaming means you putting out a response one by one, and that's simply it. The rest of the code is just a matter of schema. For example, on the start of the conversation, we have the tool, right? If it's a SQL query, then this JSON file defines what that tool is. We have a name, we have a description, and then we have a schema of what that tool is doing. This is required for the large language model to know if user says something that requires calling, right? If it requires that tool, and that's the name, that's the description, large language model will physically read this and trying to call it if that's required by the user message. So that's the beginning of the conversation, and this starts the life cycle, right? Within the life cycle, you also have a continuous message incoming, and that continuous message incoming, maybe it's from the LM, right? The response coming from call Claude, that's coming from the large language model. So let's get that in there, and then here we have a while loop that reads whether there's a tool calling or not, right? So in this response, there's a stop reason. Here it can be tool use. If it is tool use, let's see what the tool is. Right here, we have tool use being detected. If it's detected, we have a result that's from SQL query. And then here we have tool ID, things like that, so that we know which tool that we are using. And then based on whatever that chat messages is, which has the result coming from the function of the tool calling, then let's send that into another large language model function call, and we get a response back. So on this line 122, this response already have the chat messages being created here that already has this result from 118. And then look at this result 118 is being defined on line 110. And that's the important piece because this result has the result coming from running SQL query against your database. So there you go. That's how this code is being designed. Now let's go to our terminal window. And then I am going to do a source davinv bin activate. This is going to activate this current virtual environment. So that's why you see project 2, which is where we are currently right here. We can verify that by printing out the working directory to make sure that we are in the right working directory. So there you go. Now we're all set. We can then do UV sync to make sure that we are up to date. Packages are all up and ready. Now we can then run the whole thing. So since this is a chainlit package, what we're going to do is we're going to do chainlit run app.py. We're going to hit enter. This is going to physically loading the Vim file, get the secrets. So there you go. Now I can talk to it. So on the left-hand side, if I say hi, it will just say, hi, I'm a SQL assistant. And then you see that here we have 200 API call success, which is good. So that means everything is working. We're able to make API call. The API key is set up correctly, things like that. So that's a good sign. If I say something that doesn't really relate to what the goal is, right? If I just say, tell me a joke, then it should be able to guardrail against that, right? Say, I apologize. I am just a SQL assistant. I'm not programmed to do anything else, right? So it guardrail against other content that user try to enter that has nothing to do with what we're talking about, right? You tell me to build a SQL agent. That's what we're doing. If there's something else, let's not touch it, right? So that's what's going on here. And then on top of that, we can say something about the actual job, right? Something about the actual goal of why we're here, which has something to do with the table. From the user perspective, they are not really supposed to know what's inside of this table because in reality, this table could be quite large, right? It could be quite large. And then especially if you're working this at an enterprise level, this table could be billions of rows. So at that level of scale, you want to be a little bit careful of what you say. For example, you should probably start with show me top 2 rows in the table. So it should be able to write a query that limits to 2, right? That makes perfect sense. That's what I did. It's also going to continue to run until it's successful. So up to a certain point down the road, it's successful, it's able to fix this query, and then it's able to run against it. So here, let me scroll all the way back up. You see that it tested a couple of different tries, right? And then maybe it works, maybe it doesn't. Here, in this case, it doesn't work, right? There's an error code. And then it's going to continue to correct its SQL query, see it regenerated another one, and then it continue to run the query until it's successful, which I thought is very interesting. Here you go, right? Top 2 rows, that's the SQL query. It ran the SQL query against database, and then here it shows us the top 2 rows. We can then look at it, right? User ID 1, Alice, transaction ID 1, 105, and then the status is approved, right? You can then go to your database and look at the data, and you can see that there's 1 Alice, 100 approved, right? That's all here. So we're looking at the first row, which is Alice, and the data is correct. Good. So now we have a little bit of confidence of what's going on. We can then look at maybe you're interested in username, right? So what are the unique username in the table? That would be something that maybe it's interesting to see, right? Who are the users? Are users unique or are there too many users? Things like that. So it's able to write this SQL query for us. Distinct, obviously, that's something we're looking for, right? It kills the duplicates, right? So it counts a unique. And then hopefully this runs correctly, which it did. It tells us Alice, Bob, Charlie. So there's 3 usernames. Those are the unique levels. Now let's go back to our database. Let's just make sure we're talking about the same thing. Alice, Bob, Charlie. Bob here is a duplicate. We do not count that, right? So total, there should be 3 people, Alice, Bob, Charlie. Okay, so that's another success, right? We're good to go. And then on top of that, you can probably calculate something a little bit more interesting, right? What is the average transaction? So there's a little bit of algebra going on here, right? In this case, we're talking about average, right? Average is algebra. You can use SQL query to do that. If it runs it, it should be able to get us the average, right? So it did run it. That's the average amount. Great, 187. So let's take a look at that, right? So what data do we have? First of all, we're looking at transaction. Second of all, we're looking at average. At least that's what the user asked, right? Average transaction. And then let's just make sure that this number is correct, right? So how do we know that? Let's go back to our table. So in our table, we have transaction, right? Transaction amount is here. So we can take these 5 numbers, and then we can go to just a browser, right? So you enter this 5 number, and then we can then sum them together. I'm going to do this complete manually. So there's no monkey business, right? We know that for sure this is correct. We sum them together and we divide it by 1, 2, 3, 4, divided by 4. We hit enter 187, right? So 187, that's correct, right? So now we have a confidence that not only is this math correct, it ran against the query, ran against the database, and it correctly answered the question. So there you go. Hopefully everything makes sense. Hopefully everything is interesting for you guys. What I'm going to do next is I am going to cancel it. I am going to upload this on GitHub repo, and then you can access it in the bottom of the video. Thank you for watching. Hopefully you enjoyed it, and I'll see you in the next episode.